Okay, so we left off on 82.2. So this is 82.4. This one is a little bit different because it has a coefficient in front of that e. So you're going to have to do something with this 6. Okay, so when we have that e, in order to release that exponent, we need to take the natural log of both sides. So I take natural log of 4, natural log of the whole right-hand side. Okay, when you take the natural log of a product like this, it breaks down into the natural log of each part of that product. So it will be natural log of 6 plus natural log e to the 2x plus 3. Okay, so when you take that natural log e 2x plus 3, this moves over to be the coefficient. So now we just put natural log 4 in our calculator and it gives us this. Natural log 6 gives us this. And then now we have 2x plus 3 natural log e. So remember, natural log e is log base e of e. And so that's just 1, okay? Okay, so then when I put all this, I have to move this 1.7918 over here. Okay, and then over here I have 2x plus 3 equals that side. Okay, hold on, let me tell you what that is. 386 minus 1.7918, and then subtract 3, divide by 2. All right, so then you get x equals this, negative 1.703. All right, lesson 83 is over some statistics, okay? So when we have an experiment like rolling dice or flipping a coin, the sample space is the set of outcomes that are possible. So if I'm flipping a coin, I have 2 possible outcomes, heads or tails. Okay, so this is your sample space. This is the set of all possible outcomes, okay? Then the event is what we're looking for. So I might say, how many times can I get heads if I flip a fair coin? Okay, so that's the subset I'm looking for. I'm looking for heads, right? How many times can I get heads when I flip that coin? What are the odds of me getting heads when I flip a coin, okay? So 83.1 says, if I have 2 dice and I roll them together, then what is the probability of getting a 7? And then the probability of getting greater than 8, all right? So when you have these 2 dice, if you roll 1, you can get these choices, 1, 2, 3, 4, 5, 6, okay? But we're gonna combine what we roll, 1, 2, 3, 4, 5, 6 on the second dice. So this is dice number 2, this is dice number 1, or die, I don't know. Oh, sorry, I wrote a 2, but I said 1. So when I roll it, if I got 2 1s, then the outcome I get is 2. If I roll a 2 and a 1, the outcome I get is 3. So this is the table of my sample space. These are the possible outcomes that I can get when I roll these 2 dice. And so the first probability is the probability of getting a 7. So all I have to do is look down here and see how many 7s there are in this table of possibilities. And I see that there are 6 7s. So that's what I have here. The probability of getting a 7 is 6 out of the total sample space, and that's 36 possible. That reduces to 1 in 6. So the probability of getting a 7 is a 1 in 6 chance. All right, it's actually the greatest of all these outcomes. All right, and then the probability of getting greater than 8. All right, so I don't include 8. This is out. But anything greater than 8 counts. So this, these 2, these 3, and these 4. Okay, so that's 10 total things out of the total 36 again. And that reduces to 5 out of 18. Okay, so that's the probability of getting something greater than 8. All right, independent events. Those are events that don't have any effect on each other. So if I say you're going to flip a coin and I'm going to flip a coin, whatever I roll or flip whatever I land on, if I get heads, that doesn't affect you getting heads or tails. You can still get heads even if I get heads, okay? So these are independent events that are not going to affect each other. The probability of those events happening in a certain order is going to be the product of those probabilities. So in other words, if I say, what's the probability of me getting heads and you getting heads? Mine's a 1 and 2, yours is a 1 and 2, and so it's 1/2 times 1/2, okay? So the first example says, what are the odds, or what's the probability of getting heads 3 times if you flip a coin 3 times? So then that's the same thing. You could get heads 1 out of 2 times. Then the second time you flip it, you have a 1 in 2 chance. Third time you flip it, you have a 1 in 2 chance. So the odds of getting heads all 3 times is a 1 in 8 chance. Okay. Now they talk about the term with replacement. With replacement is in regards to something like if I'm pulling a marble out of a bowl, okay, do I put it back or do I keep it out? Okay, with replacement means I put it back. And that matters because it changes the probability if you don't put it back versus if you do put it back. Okay, so the first example they talk about is with cards. And they say, okay, we have a deck of cards, and if we want to pull 2 random cards, what are the odds that we will pull a red card and then a black card, and it's without replacement, okay? So we're gonna take the first card, and then we're gonna keep it, and then we're gonna draw a second card. So we're not putting it back in. So the first probability, the odds of getting a red card on the first time are half, because half the cards are red. So 26 out of 52, which is 1/2, okay? But I pulled out my red card and I kept it. So assuming that first card is red, now I only have 25 red cards in the deck out of 51 total cards, okay? So my probability of getting black, so this is the probability, oops, changed over on me. The probability of getting red the first time is this, and then the probability of getting black on the second draw is now 26, because there's still 26 black out of 51 total cards, okay? So now the total probability of getting red and then black is 1 out of 2 times 26 out of 51. So 2 and 26 can reduce so that you get 13 out of 51. The odds of getting a red and then a black without replacement is 13 out of 51. All right, if at any point you need to pause it to look at something or whatever, you can do that. Okay, so lesson 84 is about factoring, and we kind of talked a little bit about this when I was talking to you yesterday. And so we remember some of our basic factoring things, okay? Difference of 2 squares. If I have something squared minus something squared, the factored form of that is this, okay? So if I'm looking at 1 minus cosecant squared, this is the difference of 2 squares. This is 1 squared, this is cosecant squared. So 1 plus cosecant, that's not squared. 1 plus cosecant x, 1 minus cosecant x is how that breaks down. Same thing here. Sine squared minus cosine squared is sine x plus cosine, sine x minus cosine. And then this is a difference of 2 cubes. This is how that breaks down. Oh, wow. It wrote funny on me. Difference of 2 cubes is factored like this. And so you probably remember that from when we did lots of factoring, okay? But you're going to keep those factoring rules in mind because they're going to be asking you to simplify some things, okay? And these are kind of like baby proofs, just like we did in that other lesson, where you're looking to make these trig identities, okay? So we're starting with sine x minus sine x cosine squared x. All right, so this is where we're starting, and this is where we're going. Okay, we want to try to get the left to say sine cubed x. Okay, so the first thing I want to look at is, can I factor anything? Can I pull anything out? Can I change this? And I notice that I have a sine x in both of these terms. And so I can factor out sine of x. So if I pull out sine of x, what's left is sine of x, so that's pulled out. And if I take it out of here, I have 1. And if I take it out of here, I have cosine squared x. Okay. So now I'm looking at this here. Well, it's a difference of 2 squares, but it's also, I'm trying to get to here, sine cubed. So breaking it down as a difference of 2 squares is not going to help me make it say sine. But I do have a trig identity that says sine squared x plus cosine squared x equals 1. All right, and so if I rearrange that, 1 minus cosine squared x equals sine squared x. So I can basically replace this whole expression with sine squared x because it can replace this. Okay, that's on those trig identities that they gave us in the other section that you have to kind of remember. So now I have sine x times sine squared x equals sine cubed x. Well, yep, those multiplied together give me sine cubed x. So now both sides match. So I'm done. All right, so the next one, where am I starting? Where am I going? Here's where I'm starting. All right, with all this on this side. And somehow I'm gonna like simplify all this until it says secant squared x. All right, so this one looks like it's gonna be a bit trickier, but let's see what we can do. So I'm noticing over here, I have similar terms, top and bottom, but they don't exactly match, okay? But I also notice that I have a difference. And so I'm gonna ask myself, do I have a difference of 2 squares or anything I can replace? Well, something to the fourth and something to the fourth is a difference of 2 squares, right? It's secant squared squared minus tangent squared squared. So it's still a difference of 2 squares. It's just that when I break it down, what this is going to become is secant squared plus tangent squared times secant squared minus tangent squared. Okay? So that's how the difference of 2 squares breaks down. So we factor that and we put it here. Secant squared x plus tangent squared x, secant squared x minus tangent squared x. All right, well then I got something that matches because on the bottom I have secant squared x plus tangent squared x, secant squared x plus tangent squared x. So that matches, so it cancels out. All right, so then I just copy the rest down. Secant squared x, so this part here, minus tangent squared x. Then this is the rest of what was already there, right here, plus tangent squared x equals secant squared x. All right, well, I have minus tangent squared plus tangent squared. That's 0. So now I have secant squared x, secant squared x. It matches. Imagine that. All of that eliminated, and there it is. So it's really about factoring and replacing until we can make something look like something else, okay? All right, the last part of that section is about graphing, and it's very similar. We've graphed these sine curves before. So I'm just going to, what I told the other kids is what I'm going to give you is I'm going to give you the breakdown of what the equation does and what all the parts mean. And then you're going to try it. You're going to try this example on your own, and then there's one homework problem that addresses it. So I want you to try that for homework. So here's the equation. The general form of the equation for a sinusoid is y equals a sine of b times x minus c plus d. Okay, this is like the general form of it. And so here's what everything means. The coefficient of that sine is your amplitude. The coefficient of the x area is the period effect. Okay, it's how the period's affected. Because a typical period for cosine or sine is 360 degrees or 2 pi. Okay. The phase shift is how the minus c, what the minus c means. So if it says x minus 45, then that's a 45-degree phase shift to the right. And then d is the center line. Okay, where is the center of it? So here's my example. The first example in that section is y equals negative 10 plus 2 sine of 3 times x minus 45. All right, so this coefficient of sine is your amplitude. So this here is your amplitude. Okay. This is how the period is affected. Well, what that means is you're going to take your normal period, so 360 degrees, and divide by this coefficient. So your new period is 120 degrees. So basically this cycle, one full cycle, is going to happen in 120 degrees instead of in 360 degrees. Okay. The phase shift is 45 degrees right. And the center line is -10. So instead of starting at 0, you're going to be starting at -10. Okay? So your normal sine curve starts here at 0, 0, goes up to 1, then comes down to -1, and then it finishes up at 0 at the 2 pi mark. Okay? But the way yours is going to be is going to shift over 45 degrees. And it's going to start like this, same way it starts, but it's going to already cycle through the whole cycle in 120 degrees, okay? So that's the difference. So you're going to work on sketching this for homework, and then there's one in the section that also is a sketch. So using this knowledge of the equation, you're going to be able to sketch your graph. All right, that's all I got for you. Reach out to me if you have questions, and we'll meet next week.